Hello everyone, welcome back to LeetCode. Today let's practice LeetCode number 120, triangle. We are given a triangle array, and then we want to return the minimum path sum from top to bottom. So here let's check this triangle. The top is the 2, and bottom is this row, 6 or 5 or 7. So, and we want to find the path where we can go from 2 to 3 to 5, and the sum of the path is the minimum among all of the sums. So how can we solve this problem? At first sight, it looks like a tree problem, like the 2 here, it has a children 3 and 4. So it is naturally for us to think about something like a recursion solution. So what can the recursion help us? So let's say, so we in the recursion, the first thing is to figure out the best case. So the best case is 6. So we will go from the 2 and then go to 3 and then go to 6. And for the 6, the sum of the 6, the node here is 6. So you'll return the 6 here. And for the 5, you return 5 to its parent, and 7 returns 7. Okay, and then for this node, when backtrack to 3, we will want to take the minimum path. So what is the so the 5 here is smaller than 6. So we will take 5 and then pass itself and then return to its parent. So it will return 8 to its parent. And for the 4, it also has to decide whether it wants to take 5 or 7, and so it takes 5. So it plus 5, and 4 plus 5 is 9, and return 9 to his parent. So for the 2, what is the answer? So that is the 2 plus 8. Okay, so that is the recursion way to solve this problem. Besides recursion, we can also use memoization to reduce the calculation. Like here, in this node, the answer of this node has to be shared among 3 and 4. We don't want to calculate it again when we visit it already. So we would like to have the cache. So the cache is like the row number, let's say is R, and the column number, the key is this. Hi, let's start coding. For the recursion, I have a function. Let's call it path cost. And I will have a 2 variable is the location of the node or the cell. Okay, for the elements in the triangle. And I want to return an integer. So first is the base condition. So the base condition is when we reach the end of the triangle. So it means if the R is the last row, then we can just return the value in that element. Otherwise, we have to calculate the value, so it is the element itself plus the minimum number from the left side or the right side of the, let's say, it's children. So, and that is from, we'll call the function again. So it is the next row, so R plus 1 and the same index, or the plus 1 index. Okay, This is our answer here. So in order to use the memoization, I just use the cache function here. And after we have the recursion, we will call it that function. And we'll start from the top of the triangle. So that is when R and C equals to 0 and 0. Okay, and submit. Okay, it passed. So for this solution, let's think about its time complexity and space complexity. For the time complexity, we can think about, so what are the number of the number of the recursion it has in this function, and multiplied by how it takes for a single recursion. So let's the single recursion first. So in this part, we don't see any for loop function. So for this part, we have either constant or we can just use 1. And for the previous part, how many time of recursion here? So let's see, we can see from our cache. So our cache, the RNC is our key. So there are how many combinations of RNC? We have n squared here. Let's say that the n means the number of rows in this triangle. So we have n squared here. And for the space complexity, let's see. So the space complexity, it actually have two parts. The first part is from cache, and the second part is from the stack, the recursion stack. So for the cache, we also have an n squared because our cache has R and C as our key, so there are R multiplied by C, and that is n squared key value pairs in our cache. And then for the recursion stack, so for each recursion, what is the deepest number of recursion? So we will have a 2 and 3 and 6 and 4. So here we reach the end. So the deepest recursion column is the number of rows. So that is the end. Okay, so the bottom-up approach actually is just look like the recursion way. So we start from the last row and then iterate each row to find out the answer. So when we are in this row, we will have we can have two solutions here. One is to replace the array, like for the 6, we have a 6, 5, and 7. So when the 3, it has to choose whether 6 or 5. So it chooses 5, and then we replace the number in 3 to 3 plus 5, and that is 8. And so here we replace it from 4 to 4 plus 5 to is 9. So here we have 9 and we have 8 and 9. So in the parent node 2, we can just choose plus s, that is 10. So the 10 is our answer. So one way is to just replace the input array, and then we can find out the answer. But that is a question if we can really replace or update the input array. So that is a question we have to clarifying with our interviewers. Maybe this is a multi-thread environment, so the array could only be readable, is not writable. Okay, but if we can replace it, that is the solution. For the bottom-up dynamic programming solution, like we have a variable and it's called the below row, and also we have another variable is called the current row. Okay, they are all an empty list. So in the beginning, our below row will put the element from here, the last line of the row of the triangle it will have. 6 and 5 and 7 put it here, and then our iteration starts from the one row upper than the last row. Okay, so we start from 3 and 4 here. So for the 3, you can choose whether this index 6 or 5. So you will choose the smaller number, that is 5, and the plus itself, so 3 plus 5 is 8, and put it here. Put it in the current row. And for the 4, you can choose whether 5 or 7, right? 5 or 7. So you choose 5 because 5 is smaller, and the answer is 9. And also we put it here. So we finish this iteration, and then we will put this number into our below row. So we have 8 and 9 here, and the current row is now empty again. And then we have our pointer now points to this row. So it's not pointer, actually it means that we have finished this iteration, and now let's start this iteration. So for these two, you can either choose 3 or 4. So, and the two corresponding value in the below row is these two numbers 8 and 9. So you can choose, so it will choose 8 because that is smaller, and then we put 2 plus 8, 10 here. Okay, and that is our answer. So in this way, the time complexity will be, we'll also have to traverse all the elements in the triangle, and then that is n squared. And for the space complexity, it is n, because we have to these two kind of the list to store the temporary calculation. So the space complexity would be n. For the dynamic programming, first we have two variables. So one is called the below row, and it is now points to the next line or the last row of the triangle. And then we have to iterate from this row to the top row of the triangle. So in -2, -1. Okay, so for every row we have a variable, an empty space, an empty list. Let's call it the current. So for every row we have to iterate of every column in the row. So that is the C in so our current will append the number itself and the smaller number from the left or the right children. So that is it itself plus take the minimum number. So that is the this number or the C+1 or number in the C+1 index. Okay, and after this iteration, we will point the below rows to the current. Okay, so it's like after that we can return. So the answer will store in our current or this below row, the first element in the list. Okay, let's try. Pass. Okay, it passed. Thanks for watching. If you like my video, please leave a like or subscribe to my channel. Thank you.